everyone, welcome to our video on mole conversions. This is basically unit analysis. So you have already worked with this and we're going to start with the molar mass. Molar mass, how do we determine the molar mass of an element or a compound? So for elements it's very simple. We have the periodic table and here we have all the information that we need. Suppose we want to know the molar mass for hydrogen, so we will just take a look here and the atomic weight will give us a molar mass. In this case it's 1.00794 and the units will be grams per mole. Now what happens if we are not talking about just one element but we want to know the molar mass of a compound? For example, here we have aluminum sulfate and we see here that we have more than one element. We have three: aluminum, sulfur, and oxygen. So let's begin by finding out, so I'm going to paste this here, the molar mass for aluminum sulfate. First, we will make a list of the elements we have. So we have aluminum right there, we have sulfur, and we also have oxygen here. Now we need to go back, to the periodic table to find the atomic weight for each of these. So take out the periodic table. Remember, you have one in your student agenda, and if you need to pause the video so you can take notes. So I already did that, and I have here the molar masses. So for aluminum, the atomic weight for aluminum will be 26.9815. This will be grams, our units will be grams. For sulfur, we have 32.065, and these are also grams. And for oxygen, we have 15.9994 grams. So these are the atomic weights for each of the elements. Now, let's take a look at our compound. We have two atoms of aluminum, so this number has to be multiplied times 2. And here we have this unit, sulfate, is repeated 3 times. So there's one atom here, one sulfur atom, but we have 3 of these units. So we actually have 3 sulfur atoms. We're going to multiply this times 3. And finally, we have oxygen. So sulfate has 4 oxygens. However, the unit is multiplied 3 times. So we have 4 times 3, 12 oxygen atoms. We multiply this number by 12. Now, when you do that, you will get a result. So please go ahead, pause the video, take out your calculator, and I will write the result. Okay, so I had to erase my previous results here for the atomic weights, but I wrote the result of the multiplication here. So this will be for aluminum. That was atomic weight for aluminum times 2. We get this number. Units are grams. This is for sulfur. Remember that sulfur, we multiply the atomic weight times 3. And finally, for oxygen, you won't see it here. It doesn't fit the screen, but it's 191.9928 grams of oxygen. Finally, I have to add all of them. So plus, I add this up, and my total mass for aluminum sulfate will be 342.1508 grams. This will be equal to 1 mole of aluminum sulfate. So there is my molar mass. Now I can write it like this: 1 mole of aluminum sulfate. So I'm going to state here what I'm talking about. Al2SO4 3. 1 mole of aluminum sulfate has a mass of 342.1508 grams. So this will be the molar mass for aluminum sulfate. Another way you can write it is the same number with the units grams per mole. So that's another way you can find the molar mass of an element. Now, what we're going to do, now that we have the molar mass, is we're going to convert from grams to moles. So let's pause the video again because I need to prepare the blackboard, and we will be solving a problem with converting grams to moles. Okay, so let's begin the first problem in which we will be converting from grams to moles of a substance. Our substance is aluminum sulfate, and here we have the molar mass. Now, our problem is right here. How many moles are present in a 51.7 gram sample of aluminum sulfate? So we're looking for moles. That will be our wanted value, and the given value is 51.7 grams of aluminum sulfate. So we're going to start with our given value right here, 51.7 grams, and we're going to write it here, 51.7 grams. And we always want to label all units, so this units will be grams of aluminum sulfate. Now we will do our unit analysis. So remember, we multiply this times an equivalency. We have grams on the top, so we want to cancel that unit out. That means that grams have to be here on the bottom. So I'm going to write that here, grams of aluminum sulfate. And here on the top, I would need 1 mole. 1 mole, because that's what I'm looking for, moles of aluminum sulfate. Now, the relationship that we have between grams and moles will be the molar mass. So right here on the bottom, I would write 342.1508, and those are grams of aluminum sulfate. Take out your calculator so you can do this division. Remember, we multiply this times 1 and we divide by 342.1508. So the answer is, I'm going to write it here, just have to move a bit so I can write, this is equal to 0.15110296, and the answer will be moles of aluminum sulfate. Whoops, you can barely see there. Okay, let's move it here. So there's the answer. Now, we see that this is a very large number, and we still have to consider sig figs. So our first, the sample has only 3 sig figs. That means that my answer can only have 3 sig figs. So remember, the zero before the decimal point doesn't count, so it's 1, 2, and 3. We have to round, we have to check if we have to round up or down. This is a 1, so it stays the same. We can drop this part of the number. The final answer will be 0.151 moles of aluminum sulfate. Okay, this is your final answer for converting grams to mole. Now let's solve another problem in which we will convert from moles to particles. Moles to particles, we have to use a special number that you already know about, and this will be Avogadro's number, okay? So 1 mole of any substance will be equal to Avogadro's number of particles, and that will be 6.022 times 10 to the 23rd. Now, the term particles can mean different things. We can have atoms, molecules, formula units, or ions, or other things. Let's suppose we're talking about an element. Then, for this element, we will measure atoms. If we're talking about a compound like water, we will be measuring molecules. If we're talking about a compound like sodium chloride, we will be measuring formula units and so on. So particles can mean different things depending on the substance that we're working with. What we're going to start now is our first problem, and in this case, we want to know, let me, this way, okay, how many particles are present in 195 moles of aluminum sulfate. So again, we're working with aluminum sulfate. We already know the molar mass of this substance, and we want to know how many particles. So this is our wanted value. What's the given value here? 195 moles. We have 195 moles of aluminum sulfate, and this is the first thing we're going to start the problem with, writing down our given value. So let's begin here. 195 moles of aluminum sulfate. Now, for our unit analysis, remember, we have moles here on the top, so we want to cancel the moles by writing moles again on the bottom. And I know that 1 mole of aluminum sulfate will have, we're looking for particles. So in this case, there's really no point for us to use the molar mass because the molar mass converts from moles to grams. And I don't want to know the number of grams. What I'm looking for is the number of particles in this substance. So to know the number of particles, I have to remember to use Avogadro's number. This number tells me that 1 mole has 6.022 times 10 to the 23rd particles. In this case, we're looking, we want to use the Avogadro's number, so I'm going to write it here on top. 6.022 times 10 to the 23rd particles of aluminum sulfate. Okay, now you cannot see that. Let's move this a bit. Okay, so there we have moles and particles of aluminum sulfate. Now, what we have to do to solve this problem is we have to multiply 195 times Avogadro's number. It's divided by 1, so we're not going to do the final step. And take out your calculator so that I have the answer. Okay, here it is. The final answer is, I'm going to move here. So 1.17429 times 10 to the 26 particles of aluminum sulfate. Okay, let's move this. Okay, so we have 1.17429 times 10 to the 26 particles of aluminum sulfate. And again, this number is too large. So we have to go back and check our sig figs. We only have 3 significant figures, so our final answer can only have 3 significant figures. So this number will change to 1.17 times 10 to the 26. And our answer will remain, our units will still be particles of aluminum sulfate. So that's the final answer. Please try the problems in target number 2, which is working on pages 219, 220. If you have any questions, please let me know during class, during our work time. And I hope you learned something from this video. Thanks.